Hello students, welcome to Spectra Education Academy. In this video, I am going to explain answers for short answer type questions from the chapter Electric Field and Charges. Let us continue with the first question. State and explain Coulomb's inverse square law in electricity. So let us concentrate on statement first. Before that, we all know that like charges repel and unlike charges attract when they are separated by some distance. So keeping that in mind, we include in the statement force of attraction and repulsion. So statement is force of attraction. Force of attraction or repulsion. Force of attraction or repulsion between two stationary point charges. Between two stationary point charges is directly proportional to product of magnitude mean number, product of magnitude of those charges. So mathematically we understand that this is force of attraction or repulsion between the stationary charges. Product means multiplication between Q1 and Q2. Then call this as equation 1. In the second part of the statement, we again include force of attraction or repulsion between two stationary charges. Okay. So second part of the statement, force of attraction or repulsion between two stationary charges is inversely proportional to square of the distance between them. Square of the distance between them. So between them. So you can express this statement mathematically as F inversely proportional to square of the distance. So including first and second, we write that F directly proportional to Q1, Q2 and inversely proportional to square of the distance. So we need to explain it. In brief, let us say this is the separation. Let us say R is the separation between the stationary charges. So keeping this in mind, consider two stationary charges Q1 and Q2 separated by distance or in a medium. It can be that medium can be even vacuum also. So keeping the statement in mind, again writing the same, including first and second equations. So we write that as K into K is the proportionality constant Q1 by R square. So where K is the proportionality constant, K is a proportionality constant, which is equal to 1 by 4 pi epsilon. So epsilon is permittivity of medium. Permittivity of the medium. Then if the charges are in vacuum, so we write K equal to 1 by 4 pi epsilon naught. So there is a value also for this. 9 into 10 to the power of 9 Newton square meter per coulomb square. So what is epsilon naught means permittivity of vacuum or free space. Its value is 8.856 into 10 to the power of minus 12. So in addition to this, we can also define constant. So that is dielectric constant, or you can also call it as relative permittivity. So this is enough to represent in the exams. Now remember this equation. Remember this equation. So K is 1 by 4 pi epsilon naught if the charges are in vacuum. For the continuation of the next question. So next question is, define intensity of electric field, derive an equation for the intensity of electric field at a point. So first we need to concentrate on the intensity of electric field. So intensity of electric field is represented by capital E. Definition. So we know that suppose if there is a point charge here, this modifies space around it. We are choosing a point at a distance some r from the point charge, where you are going to place q naught. Q naught is the test charge. So keeping all this in mind, we need to continue the definition. Intensity of electric field. Intensity of electric field. Intensity of electric field due to a charge. In particular, point charge due to a charge at a point is defined as force experienced by unit positive test charge. What is test charge? Q naught is the test charge, so which get influenced by point charge. A unit positive test charge placed at that point. So placing the test charge is optional. If you don't have test charge also, the effect of the field will continue placed at that point. So from the definition, mathematically, intensity of electric field at a distance r, E is a vector quantity, force by Q naught. Q naught is a discharge. So in Coulomb's law, we got that F is equal to 1 by 4 pi epsilon naught Q1 and Q2. What are Q1 and Q2 here? In this case, Q1 as Q1 as Q, Q2 as Q naught. So therefore, 1 by 4 pi epsilon naught Q1 as Q, Q2 as Q naught. So once you place Q naught, they start experiencing the force of attraction or repulsion by R square. This is force part. Divided by, as per the definition in the intensity of electric field, divided by Q naught. So Q naught get cancelled. So finally we get that 1 by 4 pi epsilon naught Q by R square. Yeah. So brief explanation also you can give. There is a point charge at A. There is a test charge at Q naught. Consider a point charge Q at A. There is a test charge. Q naught at P. The separation between them is R. So again, we need to continue the definition and equation part as usual. So this is enough to write in the exam. So to get full marks. Let us continue the third question. Derive an expression for the couple acting on an electric dipole in a uniform electric field. So first thing is we include the dipole moment. So understand the dipole moment P. Dipole moment is denoted by letter P. Dipole and dipole moment. Dipole. Dipole means it is an arrangement. It is an arrangement having two charges of equal magnitude but opposite sign. Having two charges of equal magnitude, of equal magnitude, of equal magnitude with opposite sign, with opposite sign. So dipole has dipole moment, dipole moment. So dipole moment is expressed with the letter P. It is a vector quantity. So it is a product of magnitude of either charge. It is the product of magnitude of, so any one charge, either positive or negative, you can take magnitude of either charge and distance between them. Distance between them. So remember, electric dipole moment P is always from negative to positive charge. So therefore, this is 2L, or you can say 2A also, you can call it as. So mathematically, P is equal to 2L into Q. It is a vector quantity. Next, now let us continue the answer. Derive an expression for the couple acting on the dipole in a uniform, which is placed in uniform electric field. So uniform electric field means what? Field lines are parallel to each other. Tangent given, this because these are all the lines of force. Tangent given at any point on the field line represents that electric field at that point, direction of electric field at that point. So this is how you need to draw electric field lines parallel to each other. In this electric field, you are going to place dipole. Yeah. So electric field is always from positive charge to negative charge. Maybe started from infinity and extended up to infinity. Now let us draw the dipole. So take care that in case if negative, you're directing negative side of the field, that side you give positive charge of the dipole because positive and negative get attracted. The side on which the positive of the electric field is there, you give the side negative charge because there is a chance for negative charge to get attracted towards the positive of the field. So therefore, this positive charge will experience force like this. This is force on the negative charge of the dipole by the field. This is force on the positive charge of the dipole by the field. So therefore, this is force. So in the definition of intensity of electric field, we got the equation that F by Q naught. So force experiences. So F can be represented as Q naught into E. So therefore, this is Q naught into E. Even this is also Q naught into E. So therefore, these are the two forces. So consider a dipole, a dipole of dipole moment, dipole of dipole moment P is placed in uniform electric field, uniform electric field, uniform electric field of intensity capital E. Let theta be the angle because here itself you can give. Let theta be the angle because this is center of the dipole. The distance between the two charges of the dipole, as we mentioned, it is 2a. Either side is a. Either this is center of the dipole. From here to here it is a. From here to here also it is a. So therefore, the theta is the angle. Is the angle between the dipole moment. Dipole moment P and electric field E. So dipole moment is always from negative to positive charge. Yeah. So if you want torque to act or couple to act on the dipole, so there must be two forces. Their magnitude must be same, acting parallel to each other and along different lines of action. So that constitutes. So when two forces having same magnitude, acting parallel to each other, along different lines, constitute couple. This is the definition of couple. Constitute couple. So mathematically we write that couple equal to perpendicular distance with force. So what is perpendicular distance? Is perpendicular to the direction of force. So this is going to be the perpendicular distance. So you can say that sine theta equal to perpendicular distance by hypotenuse. What is hypotenuse here? 2a is the hypotenuse. So therefore, from the diagram, sine theta equal to opposite is perpendicular distance divided by hypotenuse. So hypotenuse is 2a. We can say that perpendicular distance is 2a with sine theta. Then next term. So force, we already said that force equal to Q naught into E. So Q naught is the first charge. Otherwise, you can simply write Q. Q is the first charge of the dipole and it is with positive sign and other charges with the negative sign. Positive and negative sign. So therefore, you call this equation 1. Call this equation 2. So torque or couple equal to R perpendicular is replaced with the 2a sine theta and F is replaced with the Q into E. So you know that dipole moment has 2a into Q along with E and sine theta. So therefore 2aq is dipole moment, E sine theta. So as per the cross product definition, so if you remove sine theta, we can express this as P cross E. So it is also one of the example for the cross product between two vectors. Thank you very much, students. In the next video, I'll continue with the explanation for the other three questions. But don't forget to share and subscribe with your friends and relatives. Thank you very much.